Oh, I was like waving, but obviously I haven't got my camera on. Hello. You talking, Dan? Because I can't hear you. Yeah, I can't hear you. That's it. Can hear you now.
Oh,
It's gone quiet again, by the way, just in case.
can you hear me?
Yeah. Yeah.
Okay, super,
Okay.
fantastic. Right. Can you hear me, Kaleem? I take it you can hear me as well. Okay, super. Thank you. All right. So, hello. So, this is what's been. Oh my God, Kaleem's on the on on the tube. Okay, that is proper connectivity. Okay, so uh, welcome to this AI Scientist presentation. So how this happened was I decided that I was going to spend Christmas and New Year trying to get this AI agent working properly. So Danny Laxono, one of the guys doing a PhD as well with us, he seems to be like on the bleeding edge of the info as it's coming in. And I think like a day or two after this AI scientist was mentioned in August last year, he posted it, God bless him, in our chat. So I looked this thing up. It looked very promising. So fully automated, open-ended scientific discovery, like give something a topic and then it writes a paper for you. And I thought, okay, right, it's worth looking at this. And I did. And then I parked it for a while and I figured, well, I have other things to do. And someone reminded me of the same thing like 2 or 3 months later. And I figured I have to come back to this. And then finally I gave it a go. So when this thing ran right now at the end of the year, these were the results I had. Oops, why isn't this okay? So this is one paper it wrote, the whole thing. So it looks like a real paper. It made up a title, so it had a topic to work on. And this relates to compressing data before we give it to a neural network. So me and Kaleem, one of these afternoons, we were walking down to Tesco and we were talking about compression and we said, what if we compress the data before we gave it to the neural network? It would be more efficient, hopefully. The neural network could be smaller, it would need less parameters. And if the neural network could learn from a compressed data representation, it would make hopefully the whole thing more efficient, like less electricity, smaller models. And people are a bit concerned more and more about AI not being green and so forth. So I figured, well, that's a good starting point. So this is one, long story short, after setting up everything, this is one of the papers it came up with related to data compression, and it looks like a real paper. I just put here the front page. Hello, Marella, and welcome to the AI Scientist. Season 1, Episode 1, what you've missed so far. I've just been telling Christina and Kaleem about what I was trying over Christmas and New Year, this AI agent called the AI Scientist. And this is one of the papers it generated based on one of the ideas me and Kaleem were discussing. Hello, Monica. Welcome to the AI Scientist. And so far, we've just been covering what the agent is and what I've been doing with it. So this is one of the papers it generated, and it's based on an idea that me and Kaleem were discussing late last year. Now, this is another paper it created. It created like 8 papers in total over Christmas and New Year, and I had done I don't remember exactly, I think up till 4 last year. So far it's created about 4 papers, not all related to compression. So these papers are related to compressing the data, presenting it to a neural network in the hope that the neural network will be smaller and we can achieve the same results with a compressed representation of the data. And this is something me, Kaleem, and now Niels are discussing here at the computer science department and hoping to turn this into a real paper. So, spoiler, this is a starting point. I wouldn't submit any of this to anywhere, right? And then this is another paper. So you figure, Jesus Christ, it's generating papers faster than I can read them, and it's almost at that point. And it's getting some good results as well. So in this first paper, it was getting like nearly 99%. So it was nearly matching the compression. And this is what we're interested in at the end of the day, the results. Yeah, Marella, go on. You raised your hand.
Sorry. Yes. Just a second. Where is my?
I can hear you. Yeah.
Sorry. Yeah. Good. Sorry. Right. So this is running the experiment according to your specification and writing the paper.
It's running as things stand. You need to specify the experiment. So you
Yeah.
specify a starting point and say, this is my initial experiment, and you have to run a baseline as well. And there are
Mm-hmm.
certain formatting parameters that I'll show as further in the presentation. But there are a number of things you need, well, 4 to be more precise. 1, 2, 3,
Mm-hmm.
yeah, that you need to specify before you
Okay.
start running the experiment. Does that answer your question?
Partly. Thank you. But I'll
Okay,
wait to hear more.
okay, so we were interested, and these are the results it came up with running the original experiment that I provided. So it said, well, I can get 98.47% accuracy. And we figured, well, that's good because it's compressing the data down to 36%. So it's 1/3 of the original size, and the accuracy has gone down by less than 1%. So we figured, well, this is an interesting result. And I haven't seen anything in the literature yet, it could be, that shows this angle from compressing the data set and working with smaller neural networks. So we're thinking maybe this is a promising thing to look deeper into. Okay, so next. The results are that the costs for this run are approximately $6 per paper, including tax. So at the exchange rate before Christmas, and it would give you on average 8 pages per paper and about 10 citations per paper. So just looking at that, you figure, okay, that's starting to look like a conference paper. So the short of it is the papers it's generated, like I've seen, like you guys as well, have seen a number of papers by now, and we know what a publication standard paper looks like, and this is definitely not it. So it's not what I would consider ready, like at that level to say, well, this looks like a conference paper, but it's a good starting point, I think. Like the fact that it managed to go through the experiments and get the nearly 99%, that's better than I got with my original experiment. Well, not by a lot, by like about 2% better than what I had. And I thought, well, just around 97% is quite promising already. So, and then another thing, the plots are user defined and they're data constrained. So you need to define what the plots are going to look like and what data is going to be given to the plot. So as things stand, the agent itself cannot go out on its own and decide that it's going to get a different data set and generate different types of plots. And the improvements I see is it needs more references, and that implies reworking the semantic scholar API search. So this agent relies on a semantic scholar API. It's out there, it's published, I've been using it for a number of years, and it has an enormous amount of metadata. And what the AI agent, this one, the AI scientist is using, is a very small subset. Now, there's some implications because the more data you use, the more data you're sending at the end of the day to the LLMs who are doing these write-ups, the more data you send, the more expensive this thing turns out to be. So for instance, in its current form, the agent is only sending abstracts to the LLM to decide what it's going to write about in the introduction, etc. If you start seeing like full articles, I could see the price of these papers going up by a factor of 10. So it's not going to cost 6 USD, it's going to cost 60. And then it starts turning into a very expensive hobby, right? Because as things stand, like over Christmas and New Year, I think I spent about £80 between paying for my monthly subscriptions plus paying for these papers. And you figure, well, you know, it was kind of a little present to myself, but I wouldn't want to be spending £80 a month on these things. And if it was going to go up by a factor of 10, well, at that point you think, I need to get a job at one of these places that are manufacturing these bots. Otherwise, you know, I'll go bankrupt very quickly. And then ability to create new plots. This would require extensive rework as well, because you'd have to create a process that would say, go on and study what plots we could write, what other data formats we could generate, how we could generate those plots, more tables. So this, we're talking about LaTeX, generating the tables in LaTeX format, which especially OpenAI got quite good with. And so, you know, the tables can be generated, but this requires rework because it also depends on the output data, and that's defined by the researcher from the outset. The agent itself does not define what kind of data it's going to output. And then another thing, another improvement, and this is the one I'm actively working on, is the ability to do literature surveys only. And I put this in the category extensive rework required. Like I'd like to give it a theme and say, go in, research this theme. And now we're talking about sending more data to the LLMs and a very likely increase of a factor of 10 in the price per this literature survey. But this is what really excites me about this agent, that it could potentially pick up a topic and go and do a literature survey. Okay, so what is AI Scientist? Basically, this is what I've covered already. They claim to want to fully automate scientific discovery. I think it's a good step in that direction. Then the functionality is generate novel ideas by using the Semantic Scholar API and write code using Aider, which is an application that's been out there for a while. It's the backbone of the Cursor IDE, which is a very popular, Kaleem used it for a while, a very popular integrated development environment for software development. And then you have templates, and the AI Scientist code base, as made available on GitHub, provides 3 that you can start with. Then system requirements, the people who wrote it said, well, you need GPUs, all sorts of things, but I ran it on a very small laptop and it worked okay. It chugged along, and it produced quite a number of uh, papers. And then it can use a number of large language models, and you need API keys and prepaid credits unless you have like a monthly plan to run this thing. Safety and deployment is a consideration. This is discussed by the authors because really you're leaving something unattended on your machine running code. And then it happened to me that I had these experiments running, And then I went to sleep and woke up the next day. And then it decided that it would be a good idea to start adding noise to the data. And I was like, stop, stop. This wasn't what I meant. No, this is not about adding noise to the data. But by then, probably like 10 pounds had gone down the drain because it had produced 2 papers with noise already. So, and so you figure, okay, that's kind of disastrous, but it didn't delete any data. It didn't decide that it was a good idea to delete like all the contents of the hard drive, but a Docker image, which is a containerization platform, is provided, and I have run it on Docker and it works okay. So worst case scenario, it would delete everything that's in the Docker and extinguish all your credits, but it wouldn't do any damage to like any physical hardware. So the paper is on archive, and it's got about 70 or 80 citations so far. It had like a spike, and then now it seems like people lost interest. The company website, Sakana AI, they're based in Tokyo. In the news, they raised over $200 million. They're backed by NVIDIA. And all this happened back in August, September. As soon as they released this, they had been going for a year already. NVIDIA became very interested, and this project on GitHub remained dormant. But I imagine with 200 million, they must be hiring like crazy, researching and so forth. So they must be doing well. Now, the rest of this is all techie stuff. So how to prepare the environment, how to prepare the templates, and how to run a baseline, what the mechanics are of how these prompts are happening inside the codes, what the execution sequence is, and how the ideas are generated, the plots, how you can monitor and stop the experiments. As I just mentioned, I didn't want noise to be added to my data sets, how you can restart, what is going to end up on your file system, and what these experiments look like, what the artifacts are, the actual data that the models produce, the LaTeX template that it used to edit, what that template looks like, and then the write-up. Now, I actually prepared an experiment which I'm going to run now. So I said, run it, and so it says, okay, let's go and run this experiment, but we're only going to generate one idea. And so now it says, and so it's off doing its thing now while I go over the technical bits, which are a bit boring. It's not like super interesting. It's just like how this thing works, how it's generating these ideas, and like checking. I don't know if this is very readable on my screen, but it's saying, well, I'm checking for novelties, and it's a lot of it is JSON formatted. And this is basically the agent running in the background going to, okay, so this is an error I get occasionally that semantic scholar isn't available. And that's life. Let's see if that can be fixed on the fly. And that's in do search semantic scholar query. Now that's been fixed. Okay, so that's a semantic scholar learned. So that's not working. It found some ideas, and basically that's going to carry on going. Right. So that's the actual agent running and saying, I'm going to now produce a paper. So the rest I had in terms of slides, failed to evaluate, no such file templates, demo run, final. Oh, I see. Sorry, I need to fix something. I copied this for the demo, but we actually need uh, the baseline, which I did not run. So I'll just have to fix that quickly. And the baseline is going to be this guy here. Compressions. Oh, the baseline is on my laptop. Right. Guys, I'm just going to go back to the slides to the plumbing, and on the laptop, I'm just going to add the run to git pull. Copy. Sorry about this. I did not set this experiment entirely up correctly. Home, git, AI Scientist, and templates, and compressed CNN. Where's the demo? Mhm. Okay, right. So CNN, plot, run, copy, templates, paste. Right, sorry guys, so what I had was a compressed CNN folder, and I didn't copy everything I should have to my base run. So it had a baseline to start with. So seed ideas, don't need that. Experiment, run. Right, that should do now. Plot.py, templates, demo, paste. Okay. Okay, so now git pull, we should have what we need to run this thing. And start again. Okay, sorry about that. And right, so now back to the plumbing. And this is a bit boring because it's like, so this thing is running in the background, and I'll just go over some bits I find really interesting and difficult. Like it's difficult to get my head around this because it's prompts, generating prompts. We're all familiar with the concept of a prompt. And like, well, we have to write prompts and we get a reply back from a CNN. So just go over how this thing is set up. So if we wanted to run an experiment, so let's say Mirella had an idea, or Monica had an idea, or Christina had an idea, and say, let's see what it comes up with, right? And I'm totally open to this, and I'm happy to pay for it, like just so we see what result we get. So we say, well, I have an idea for an experiment, and it's kind of related to Christina's doing a master's degree related to such and such. Can this thing help me in any way, direct my research, help me with the experiments, come up with some interesting citations I haven't looked at? I think this could be a valuable tool. and I'm open for collaborations. So if you guys have any, any thoughts in that direction, feel free to ping me. Just going over the preparation. So there's a template directory, and we can copy that template directory to start with. And we have a LaTeX folder that in this case has like one ICLR template for it, which based on that template, and then we create an experiment.py file with one single command line parameter, which is the output directory, and that defaults to um, run_0. Then we copy plot.py from a neighboring project to adapt it. This is the code that's going to plot for us. And the structure of this AI scientist is expecting that there will be an experiment.py, a plot.py, and a LaTeX directory. And then the next thing, we have to create a prompt.json file. So it's JSON structured file. And then it has some attributes such as the system. So its system is a directive of a prompt that's going to say, well, what are you? What role? Like there's this thing about role playing and what role the LLM is going to take when it replies to you. So such as you are a kindergarten teacher and teach a child how to perform basic arithmetic. So that's the language the LLM is going to use. So in this case, it's saying you're a postdoc researcher who's looking to publish a paper that will contribute significantly to the field. And then there's a description of the task. So that's the prompt, and it's given to this is a file that the AI scientist will read as it's doing its work. It'd be interesting to try this, right? And to create a paper for a 10-year-old, see what it comes up with. And all we have to do is modify this system prompt. So I'm past that Christmas kind of phase. I might not be spending $6 to find out, but it would be funny. Yes, Monica?
Sorry. Just a question. Do you provide also some initial literature with the prompt or with ideas? I don't know.
Yes. So it's not the initial literature itself, but this is the seed idea.json file. And you could have one or more seed ideas. So there's and the attributes here are name, title, and experiment. And that would more or less guide which way you'd want this thing to go. And I imagine in the experiment description, you could say, well, base your work on such and such a paper. I haven't tried it, but I imagine it would be the kind of thing that. So does that answer your question? Okay. So what happens next? You run a baseline, and that's from your template directory, py output directory equals 0. So hopefully that's what happened in my code. Oops, false. What happened here? It failed. Anyway, let's go back to here. Run the experiment from the root directory, and then run the run the baseline Python experiment, and then run the experiment itself. So when the experiment is running, and you're saying, okay, we're going to generate ideas, we're going to check the idea novelty. So this is like the main script. And then this prompt generation starts happening. It says, well, go to the code, get my experiment.py file, stick it in here. The task description, you stick in this here where we saw before in our prompt.json. So it starts building this prompt here based on what we've defined in our JSON files. And then once it builds this, it says, okay, go to the LLM, get response from LLM, put all this prompt that was built and give me a result, which is going to be our JSON output. And then it iterates through these seed ideas. So that's the basic iteration. where this AI scientist is building these prompts programmatically and changing them programmatically based on the number of seed ideas we gave to it. So we're using LLMs at this point. And then we check an idea novelty. So we have like, and so this is what we call in Python a formatted string. There's some text here in curly brackets that are substituted further in code. So we say, well, we're going to change the task description, we're going to change the codes, we're going to change the number of rounds. And as it's iterating through these experiments, it's changing these fields. So what happens next? Well, it goes to searches for papers, it picks title, authors, venue, year, a number of citations and abstracts. So we can see straight away that the actual agent is not looking at any of the content of the paper, and you'd think, as I did, well, this is kind of limited because it's basing all this text that it's writing about this topic. You ask it to research on abstracts only, and you figure that's a bit limited. I think at least the conclusions in the introduction, a bit more, and ideally everything. But again, as I mentioned, if you put the entire paper in, you look, and sometimes these papers run into tens of pages, you're looking at the cost going up, I would say by a factor of 10. So at this point, we're searching papers, and then we run the experiments. And at this point, we use this thing called Ada, which is this automated code writer. And that's it. It goes off and executes the code, performs the experiment, gets the results, gives it back to the LLM. If there's an error, either then the LLM says, oops, there's an error here, let's fix it. It gives it, the code is rerun by Ada, and this keeps running for a while, as many times as you asked it. And then it gives you some results. It saves the best model, the weights and biases, this PTH file. It saves all the results for training and testing in an HPI file, and the final info in a JSON file. And this is what the final info looks like. It says these were your means for best accuracy, test accuracy, total training time, and so forth. You can monitor the experiment and you can interrupt it, which, as I said, is good because sometimes it might start trying stuff you didn't want it to try. And then, so you can, if you observe anomalies, you have the options of rerunning the experiment, skipping idea generation and novelty check. So if you've checked those, you've run those things already, you can say, right, skip those bits. You could, in fact, edit ideas because it generates a list of ideas, and then you end up with a structure of folders that looks like this. So each one of these folders was a run, and as you can see by the dates, I ran quite a few on Christmas Day and Boxing Day. So 25, 26. So, and that's what the outputs look like, the runs, and each run contains the best model and the 3 files basically for each run. And then there's a notes text that the AI scientist uses to base the final write-up, which, as I mentioned, is limited because it's based on results in an abstract. So I guess that's whatever the LLM comes up with. Those are the results for every run. That's the LaTeX template, what it looks like. So Monica would be very familiar with this, and Christina might have seen this at some point if you're using this to write your coursework. This is what the actual template looks like. So you can see, well, abstract here, intro here, and the AI scientist goes and says, right, it's time to write the abstract, modify this part, and then Aider goes and does the search and replace, and that's quite neat to watch happening. And then, well, that's it. It performs the write-up, and this is what the write prompt looks like. So again, it's a LaTeX, it's a Python formatted string. So this would then, you'd be able to search for the abstract part and say, right, change all these bits for the abstract. Oh, sorry, this is the prompt for the abstract, what you need to do. This is what you need to do for the introduction and so forth. And that is everything I wanted to show you. Thank you so much for taking the time. And again, if you guys have any ideas that you'd like to explore, I'd be 100% happy to try it out. But this one thing, we do need an experiment to start with. I'm happy to kind of get something going, but I'm super excited about this. I'd be happy to try it out. And any questions?
Just a quick one, Daniel. It is obviously it is the purpose. It can do the paper. It can do the idea generation. But the point is that it has to be an idea that requires the coding and then running the experiment through the coding. So obviously only that kind of idea is valuable, I guess. It doesn't separate the two parts, doesn't it?
As things stand, it doesn't separate the two parts. I mean,
No,
I don't understand the process well enough. I imagine you could unpick it at some point and say, only perform the experiments and nothing else. But again, the experiments that it's doing is based on searching the literature. So it says, well, I've searched the literature and I've decided that based on the literature, I'm going to try something else. So at least the experiments are based on literature searches. And then it could be that it stopped at that point. Yeah, go on.
I have to ask you just one question then. Sorry, I apologize. Maybe I don't understand sufficiently the tool. How can it run an experiment that is based on the literature? Does it access at that point anything that is available of the literature?
Yes.
So it finds the code that the literature is referencing?
No, it creates its own code. So you give it a base experiment.
Okay, so how can you be 100% certain that the new code that has been generated and run is actually indeed either novel in respect to the one that is in one of the paper that it found, or it is structurally correct and indeed presents an evolution of the papers that it found?
So that's a good question, because I went purely on the accuracy. And as soon as I saw, okay, it got nearly the same accuracy, but with 33% of the size, I thought that's a good result. I'm happy with that result. And like, we tend to boil down everything to accuracy and say, well, if the accuracy was good, that's good enough. But you're right, there's a lot of validation that would be required. But to that extent, the actual code is all supplied. Everything this thing does, so everything it did is it creates a results. And so I'm sharing my screen with the results it generated. So every experiment it generated, it has, so the results from what it did for every run. It has notes that it wrote itself. So this is based on the experiment. So what did I try doing? And it also has the code. So it says, well, what code did I have to do to achieve these results? Now, I haven't performed like a diff to say, well, can you see what the difference is between the code I provided it and what it actually what was actually run here? So I didn't do that much, but the only thing I can say for that effect is there's a comprehensive record of what happened. And then there's also a record of what the Aider tool was doing. So it says like, well, the Aider chat started, and then it has like, well, this is the goal. And then I'll help plan the experiments based on the requirements. So that's Aider chatting. And let's try one with DCT. Let's try one with random projections with optimal learning rate. I have no idea what this is, by the way. Let's ablation studies. Well, I know what this means, right? It means removing parts of the experiment to see how they affect the accuracy. And so, and then it goes on and says, oh, see you, Christina.
Sorry,
Thanks.
I've just got to go because I had another call and I have to go back to it, and I didn't want to interrupt, but sorry, I just messaged. Bye. Thank you.
Thank you. Bye-bye. So, Monica, there's a record. Oh, you have to go too. Okay. So catch up with you later, yeah?
Yeah.
Oh,
Thank
sorry.
you very much, Daniel. It's really very interesting, extremely fascinating.
Thank you.
Bye-bye.
Bye-bye.